So let's have a look at how drugs that affect the folate system can be used to kill bacteria. So the first thing to think about is how some of the nucleic acids are made for making DNA, and it's done like this. You start off with a compound called para-aminobenzoic acid, or PABA, and that is converted to folate by an enzyme called dihydroteroate synthetase. Folate is then converted into tetrahydrofolate, and that is ultimately needed for making DNA. So there's a couple things you can do here. The folate is converted to tetrahydrofolate by dihydrofolate reductase. Dihydrofolate reductase. So one of the first things you can do here is to inhibit dihydrofolate reductase, and that's how drugs like trimethoprim work. So trimethoprim inhibits dihydrofolate reductase, and that's how it kills the bacteria, because the bacterium can't make the DNA. It's also used as an anti-malarial drug through the same mechanism of action. The other thing you can do is to add a compound that is fake PABA. Right, so let's have a look at what I mean by that. So let's look a bit more closely at what PABA actually looks like. So para-aminobenzoic acid is quite a simple structure. You've got a 6-membered carbon ring, and so it's a benzoic acid. So we have C, OOH, and then para-amino. So we've got NH2 at this end. So that's PABA. And drugs that work on, so that mimic PABA, are things like sulfanilamide. Gotta get my spelling right. Amide. And that looks like this. So we have the 6-membered ring again. Not very good at drawing 6-membered rings. We have the NH2, and then here we have SO2 NH2. Let's get rid of that. So that's sulfanilamide. As you can see, it looks like para-aminobenzoic acid, and what happens is it doesn't get made into folate.